Hello and welcome to another lesson on computer networks. Today we're up to lesson number 8 where we're going to look at network protocols. As you can see over here, there are a lot of protocols we need to cover, so let's get started.
Don't feel overwhelmed. Just do one thing at a time.
Computer standards are official definitions or rules that exist for various aspects of computing. For example, standards exist for operating systems, programming languages, communications protocols, hardware devices, and data formats. Some standards and set are agreed by official organizations, and others have become established by common use. So some of the standards you'll be familiar with are HTML, Hypertext Markup Language, USB, Universal Serial Bus, and of course Wi-Fi and the different family of Wi-Fi protocols. Hardware and software standards are very important as they allow different manufacturers to make components and programs that are compatible and will work with each other. Without standards, only hardware and software made by the same company could be used together. This is bad for consumers, it's also bad for business. A program or product is likely to be popular if it is more widely compatible and can be used with a range of different systems. Standards are particularly important when it comes to networks. Computers and software need to talk to each other on a network, even though the hardware and the software is from a variety of different competing companies. So we need businesses to agree on standards. That brings us on to protocols. We'll start with the definition of network protocol. Make sure you remember this, it is a very common exam question. A network protocol defines rules for data transmission between devices on a network. A protocol allows devices to exchange data with one another as long as they're following this same set of rules. A network protocol will include details such as how to set up a connection, how to start and end a message, how to deal with corrupt or missing data, how to format the data being sent. Networking is complicated, really complicated. So we have to use many different protocols, each with a different function. In the context of this lesson, a standard is a formalized protocol accepted by most of the parties that implement it. But remember, not all protocols become standards. Anybody can come up with a new set of rules for transmitting data, but it only becomes a standard if enough people agree to use it. So standardization allows interoperability between systems. That's a nice word, but it just means that they can work together. In computer networking, protocols describe how the standardization will work. So there's a whole bunch of protocols that you need to know, some of which we've mentioned before, some of which we haven't, but we'll just go through everything together in one place. So we have Ethernet, DNS, HTTP, HTTPS, TCP, IP, FTP, SMTP, POP, and IMAP. That's more acronyms than you can shake a very large stick at. Ethernet is a protocol that defines how data should be physically transmitted between network hardware/devices. Ethernet is used in wired networks. It is used to transmit data along cables between devices in a local area network. The domain name system DNS servers share the task of keeping track of all the mappings of IP addresses to domain names across the internet. DNS is the protocol used when your web browser needs to find the IP address of a website. So you type in Amazon.com, your computer needs to find the actual IP number, 72.21.215.90. So it uses DNS, the domain name system protocol, to look up what the actual IP address is for that domain name so that you can contact it online. Hypertext Transfer Protocol, HTTP. This is the protocol used by the World Wide Web. HTTP defines how web browsers, clients, should request and web servers should deliver resources such as HTML files. HTTPS is Hypertext Transfer Protocol Secure. Uses what is known as Secure Socket Layer, SSL, or more recently, the up-to-date version, Transport Layer Security, TLS. These ensure web page data is encrypted before being sent out of the browser or server to ensure the privacy and integrity of the data being exchanged. So, for example, logging into an account, checking your bank account online, or buying products and services online. So here is a couple of diagrams just explaining how HTTPS works. It's the idea that if you're doing it in HTTP, you're sending data plain text. Anybody can intercept it and read that data. If it's sent encrypted with HTTPS, if somebody intercepts your data packets, then they are scrambled and they are unreadable. FTP, File Transfer Protocol, a protocol used to transfer files between a client and a server on a computer network. This is a protocol that is older than HTTP. It's older than the World Wide Web. It's a protocol that I would have used back in the day if I wanted to transfer files between computers on a wide area network. Although it is an older protocol, it is still used. For example, uploading the files for a website to a web server. So if you are a network administrator, if you're a webmaster, you may still be using FTP. So you still need to know what it means. If you are describing it in an exam, please make sure that you mention it is between a client and a server. The mark scheme is often very specific. If you don't mention that, you will not get the mark. TCP/IP. This is the backbone of the internet. It is made up of two protocols used together to make sure the data that we send ends up all present and correct at the right computer. This is comprised primarily of TCP, Transmission Control Protocol, and IP, the Internet Protocol. Transmission Control Protocol, this takes the data from an application and divides it into smaller packets of data. Each packet is made up of a header and a payload. The header contains the sequence number of the packet and a checksum to allow the recipient device to check that the data has arrived correctly. The payload contains the actual data from the application that needs to be sent. So TCP takes the data from the application, for example, a web browser, and then divides it up into small packets that can be easily sent across a network. It adds sequence numbers so it can be put back together at the other end, and it adds some sort of error checking information so that the recipient can check whether the data has arrived correctly. When receiving data at the other end, TCP examines packets for errors, looks for missing or corrupted packets. If it finds any, it asks for the packets to be resent, uses the sequence number to reassemble the message in the correct order, puts all the data together, and then passes this data on to the appropriate application. So if it's receiving an email, that would go to the email client, for example. Next one up is the IP, the Internet Protocol. When you send the data on the Internet, it passes through many computer networks on its way to the destination computer. Basically, it goes from router to router to router until it arrives at the correct destination. The IP layer is responsible for addressing packets of data. It can add a destination address and a source address to all the data packets that it has received from TCP. The Internet Protocol defines how data packets should be sent between networks. An IP header is added to each data packet containing the source and destination IP addresses for that packet. Routers use this information to determine whether the data packets are destined for its own local network or whether the data needs to be passed on to another network. If we look at the whole TCP IP system, we can see that we start with some data, a message. That comes from an application. That then is divided up by TCP into small packets. These all have error checking information and sequence numbers. Then it gets passed down to the Internet Protocol, and the Internet Protocol adds those source and destination addresses. We use packets because it makes it a lot easier to make maximum use of our networks. We can divide the data into packets, and those packets can all be sent different ways between networks, between routers, until they're eventually reassembled at the destination. Each packet can make its way by a different route to any of the other packets, but they all get to there at the end, they're all reassembled, and the data is present and correct thanks to TCP/IP. This is why every computer online has what is known as an IP address. So for example, Facebook.com turns into something like 31.13.90.2. For a long time, we used what we call IPv4, IP version 4. This uses a 32-bit number to address the data. The address is broken down into 4 8-bit sections, each of which represents a number between 0 and 255. Each section is separated by a full stop, so you end up with something like 194.83.249.5. Because it's 32-bit, 2 to the power of 32, this provides just over 4 billion possible addresses. When the IP version 4 was first launched in the early 1980s, the idea that we would need more than 4 billion addresses on the internet was absolutely crazy. But nowadays, we have a lot more. In fact, we started to run out of IP version 4 addresses back in 2011. So what do? We moved on to IP version 6. We just skipped over IP version 5, went straight to IP version 6. This is a 128-bit addressing system, which is divided up into 8 16-bit sections. The addresses are written using hexadecimal, and as each hexadecimal number represents 4 bits, there are 4 numbers to each section or group. Each group is separated by a colon, so you end up with something like this. Because it's 2 to the power of 128, we end up with 340 trillion different addresses. So hopefully that will do us for a few more years. Currently, both IP version 4 and IP version 6 are both being used. Because we're talking about IP addresses, I'm just going to talk a little bit about MAC addresses as well. That's Media Access Control. This is a unique number that identifies the actual device that is connected to a network. The MAC address is part of the network interface card, the NIC, which is inside your device, usually built into the motherboard nowadays, and this number is assigned when the NIC is manufactured and cannot be changed. This is used to route frames of data around what we call local area networks. Put very simply, MAC addresses are for local area networks, IP addresses are for wide area networks, for example, the internet. Don't get them confused in the exam. And now we're going to finish off by looking at email protocols. Email is the original killer app for the internet. It's been around since the 1970s, and there's 3 protocols that you need to know about for your exam: SMTP, POP, and IMAP. If you look basically at how email works, you send the email from a client on your PC, it goes to a mail server, it then goes from mail server to mail server over the internet until it arrives at the mail server of the recipient, where it waits on that mail server until your friend's email client logs in, asks for the email, and then retrieves that email onto the PC so your friend can read it. The first protocol we're going to look at is SMTP, Simple Mail Transfer Protocol. This is used to send email from a PC to a mail server and from mail server to mail server. When it is used, the sender sends the message and does not care if the receiver is available or not. It just pushes it out there and hopes that the receiving computer is online and ready to receive the message. Now that's fine if you're sending data to a mail server. Mail servers are always switched on. But it's not appropriate for the final leg of the journey, receiving messages on a home or office PC, because these are often switched off, logged out, or just not available to receive data. So we can't use SMTP to retrieve data for the final leg of the journey. We can only use it to send. That brings us on to POP, Post Office Protocol, currently on version 3. This is used by home or office client PCs to retrieve emails from a mail server. It's important to note that the receiving computer starts the process by asking the mail server for mail, and then it retrieves that email and downloads it. So please make sure you use that word retrieve to make sure you get the marks in the exam. It's not used for sending, it's used for retrieving emails from a mail server, and it is the client PC that actually initiates the connection, not the mail server. POP is quite an old protocol. It has very limited features. Any mails downloaded to a client PC are then deleted from the mail server. So with POP, you cannot access emails from multiple devices in multiple locations. It also does not support complex searches of emails on the server, and you can only have one mailbox. So quite limited. A more modern approach is IMAP, Internet Message Access Protocol, currently on version 4. This is also used to retrieve messages from a mail server in the same way that POP does, but it is more advanced. Mail is stored on the server until specifically deleted, so you can easily access your email from multiple devices. You can have multiple mailboxes, and it's basically a lot more flexible and advanced than POP. So there you go, just a quick comparison between POP and IMAP. With IMAP, if I download the message onto my Office PC, I can then go home and see the same message from my home PC laptop. It's still available on the email server for me to read. But with POP, if I check it on my Office PC, that message is downloaded and then deleted from the server. So if I check it at home, that message is not there and I can't read it. If we take a look at that initial diagram, we can see the whole sending process is SMTP, whether that's from the client PC to a mail server to mail server. And we use POP and IMAP for retrieving emails for that final leg of the journey. The receiving computer initiates the connection, asks the mail server if there are any new emails, and then downloads the emails onto that PC. It retrieves them. That's how that works. Summary, we've covered a lot. Computer and network hardware and software is made by lots of different companies. We need these companies to agree to use standard protocols so that our devices can communicate over networks. We've looked at Ethernet, transmitting data on a wired local area network. We looked at DNS, matching IP addresses to domain names. We've looked at HTTP and HTTPS, the protocol used for requesting and sending web pages. Remember, the S in HTTPS stands for secure. That is an encrypted connection. FTP is an older protocol for transferring files between a client and a server. TCP/IP is the backbone of the internet. TCP divides messages into packets, adds sequence numbers, and handles error checking. IP addresses packets of data with both a source and a destination address. SMTP is used to send email from PC to mail server and mail server to mail server. POP and IMAP are both used to retrieve emails from a mail server. IMAP is more advanced than POP and has the ability to check multiple emails from multiple devices in different locations. Well, that is a lot to get through. You just have to learn those acronyms. You have to learn a brief description of what each does. Good luck with that. It is just about putting in the hard work here just to learn these. But once you learn them, it's easy enough to get marks. The questions aren't too difficult, but you do have to have memorized what these all mean. Good luck with that, and I will see you in the next lesson, everyone.